So we're going to be looking at some more index laws today. This one is kind of obvious compared to the one we'll do tomorrow and can be proved pretty easily just using expanded form. So we'll call it more index laws. Why did I swap between capital and lowercase? Who knows? More index laws. So let's say we've got a fraction. 2/3 to the power of 5. If I want to write that in expanded form, it's going to look like this. 2/3 times itself, so that there are 5 of them. Now let's say I want to write it in index form again. I could just write it like that, or if we remember, when we multiply fractions, we multiply the numerators with each other, the top of the fraction, and then we just multiply the denominator, so the bottom of the fraction. So 2 times 2 times 2 times 2 times 2 is 2 to the power of 5. 3 times 3 times 3 times 3 times 3, 3 to the power of 5. So what we'll see is that, let's say we've got x over y all to the power of m. Well, we can just do it like that. And let me fix that. X to the m over y to the m. That will simplify a lot of things for us when we do surds later on, and maybe there's a squared on the bottom. It means we could get rid of the squared but leave the top as a nice whole number, something like that. Get rid of the square root, sorry. Alright, I'll put that in a bit of a highlight so we remember that one. Alright, next one and final one for today. Another easy lesson. Let's say I've got 2a to the power of 4. In expanded form, 2a times 2a times 2a times 2a. Now, when there's no symbol in here, we know that that means multiply, but I'm going to write it out. In multiplication, it doesn't matter what order we do it in, so let's rewrite this. 2 times 2 times 2 times 2 times a times a times a times a. And then time to contract it again. 2 to the power of 1, 2, 3, 4. A to the power of 1, 2, 3, 4. So you can see this index here applies to the a and to the 2, which means I'm going to end up with a formula that looks like this. Let's say x, y to the power of m equals x to the m, y to the m. Put that one in a nice shiny red box as well. So those are the 2 rules for today. Let's do some quick examples with them, but they're pretty self-explanatory, so we should be okay. Alright, let's say right without brackets. Let's say we've got 3 over a to the power of 3. Well, just like we looked at, that 3 applies to the 3 and to the a. So we've got 3 cubed over a cubed, which is 27 over a cubed. And there we go. If you're planning on doing the highest level of maths, it's definitely worth learning a few of these cube numbers as well as your square numbers, just because there's a few times when simplifying things gets a bit easier. So it's a good practice to know them without a calculator. Alright, right without brackets. Let's say I've got 2 times, let's say 2 b cubed, let's say that's squared. Well, this 2 is not inside the brackets, so I don't need to apply the squared to it. But the squared does apply to this 2 and to the b cubed. So the first 2 stays the same. The next 2 becomes 2 squared. And this b cubed, well, remember power of a power we multiply. So that's b to the 6. Now let's tidy it up. That's 2 to the 1, remember? So that becomes 2 to the 3, b to the 6. And then we have it. I might do one extension-y type question. Let's have a go at this one. Let's say 3 outside of 9, a4, all to the power of 4. So 3, nothing applies to that one. The 9 we've got to the power of 4. And a to the power of 4 to the power of 4 becomes a to the power of 16. But let's say I want to simplify this even more. That 9 is actually 3 squared to the power of 4. Because 3 squared equals 9. As long as I put in the brackets, that's fine. 3 squared is 9, so all I've done is replace it. Power of a power, 3 times 3 to the 8 times a to the 16, which is 3 to the 9, a to the 16. That's a little trick that you can do, and I'm sure the textbook will ask it in some enrichment areas at some point if it hasn't already. So hop onto the class kit and then have a go at the textbook questions.